Hi my friends, today we discuss about iPart and iFactory. We'll create a part which be converted to iPart, and this is what we discussed in my tutorial number 17, but now we'll add a new parameter which will be modified when we insert the part in an assembly. What is this? This is a flexibility in preparing parts to be placed in an assembly. As you can see, here is a construction with walls. The walls are placed at some angles, and when we place the iPart, we want to modify its angle to be placed in accordance with the angle of the walls. This is what we name iFactory, the possibility to modify parts when we place them in an assembly. Let's start. We start by creating this construction as a sheet metal part with angles. It is a hexagon with flanges on its sides. As you can see, the angle in this section, the angle of 50 is between the base and the wall from the external direction. The thickness of the sheet metal is 10 and the height of flange is 300. So let's create this part. Sheet metal part. First we change the thickness from the rule with our thickness of 10 millimeters. Then we create a sketch on this plane, which is a polygon with 6 sides, like this one. We apply a constraint and a dimension 500. This is a sketch for applying the tool face. The thickness is 10, of course. Okay, we start now to place the first flange on this side with these two conditions, 300, and the angle is 1, 2, 3 for the first one. Okay, next one is placed on this edge, the same data but an angle of 90. Okay, the next one is at 75, and the last one is at 50. We select the material, steel, but the aspect we want to be clear green one, this one. Why? To be transparent. Yes, we want to see inside when we place that objects. Okay, we save this as a base component. And we go to the next one. As you see here, this is an object created basically on sweep. We create this slot, yes, and we sweep it on this midline. Dimensions of the midline are parameters: base 120, radius 20, the sloped line is 90, and the angle is alpha 45. Let's create this contour first in the plane XY as a normal part, not sheet metal part. Line to the right. We keep pressed the left button and we continue with an arc, and then we wait to see a tangent. Dimension is as I said, base equal to 120, home. I want to see expressions, and now we see expressions. The slope line is measured with an aligned dimension, sloped equal to 90, radius equal 20, and the angle is 45. This angle is alpha equal 45. Okay, we have to remember these names, but especially alpha. You can see them in this parameters table. Now we don't need to see them anymore, and we look only to values. In the plane YZ we create a sketch with that slot. I project, to be sure, I project this point in our sketch, even if it is not necessary, and then a slot of 16 and with a diameter of 8, 4 multiplied by 2, because the dimension is 4 in our drawing. We constrain the midpoint to be over the center point, and now we apply sweep because we have the two sketches. You see them here. Sweep on this steering curve, and we obtain this. Next is this rib. You see there is a rib here with dimensions 30 from the end of the horizontal line, 36 from the start of the sloped line, and with radius 60. The plane XY F7 we project as construction these two lines, then not construction, for an arc between the two lines with a radius of 60. Dimensions are 30 here and 36 up. 36. Good. Finish sketch. Rib. The thickness of the rib is 6 millimeters. This option and symmetrical on 6. Okay. Now we end this by applying a special fillet with a line between the midpoints, which must be a center line. Finish sketch. Revolve this half with that axis. Okay. Then we go here where we place a circle in the midpoint of the end line with a diameter of 2 multiplied by 20 or 20 multiplied by 2. You see these dimensions and the drawing here. Radius 20. Good. Finish sketch. Extrude this and this, yes, both to this face, but not cut, but join. Okay. Now we know that this is 8, then the radius is 4. We apply a fillet of 4 to the two sides and plus here where the radius is 2, to respect the drawing. Very nice. You can imagine that this part is manufactured by die casting. Now we apply this hole on this face with this center of 16, but to this face, not through. Okay, I want to tell you that this angle will be modified, and we can find that this hole is also machined in the bottom face. Good. The last are two holes of metric 8 at 45 millimeters distance from this end. I create a sketch here with another one point on the same horizontal with the first one, and the distance of 45. Finish sketch, hole, tapped, threaded, metric 8, isometric 8, which is through, because this is maximum 180 degrees, no more than this. Full depth. I select also the other point. Okay. Material is steel, and the aspect is gunmetal antique polished, which looks very nice. Let me apply here titanium polished. Okay, now we convert this part to an iPart. You know that procedure, and you can take a look at the tutorial number 17 at the minute 7:41. Go there and see the same thing I'll show you here, of course. Before to apply that procedure, we have to do a thing here. You see, this is the table of parameters. Base, sloped, radius, alpha are our created names. Alpha is the parameter which will be used to create parts as iFactory. We have to place it as an export parameter, and we check this cell. Okay, then we activate the tab Manage and create iPart. We recognize our names, and to this parameter we select Custom Parameters column. Yes? Okay. That's all. Now we can save this part as a variable square is the name. And then we create the assembly to place the parts. We place the base component first, grounded at origin, and then the first square, variable square number 1. You see, it comes on cursor. we want to apply this object here, that the angle is 123 degrees between external and this face. The definition of the angle alpha is reverted. So we apply here 180 minus 123. Click. The part has another angle. Yes? Dismiss. And let's place it in its position. Constrain this face on this face. Apply. And this face on the sloped face here. Okay. If you take a look perpendicular on this plane, you see the perfect match between the two angles. Yes? All we can do is to place somewhere along this line our variable square. You see here a name, 017 instance 1. If we apply the same part in other place, the name is this. But if we change the shape, the angle, you will see that Inventor asks us for a new name. Good. Place the same variable square, but another angle, 90 is the next. 90 without 180 minus 90. We know that this is 90 on both faces. Click somewhere, select a name, and the name is 018, proposed name. We accept it, okay, and we constrain this one on this face, apply, and this face on that face. Okay, let's take a look along the side. You see again the perfect match of this square in its position. Now this is a routine. Yes, variable square, the angle is 180 minus 75. We accept the name. The face, base face, apply, and vertical, apply. We couldn't apply the mate constraint if the angle is different between the two. Okay. The last is at an angle of 180 minus 50. Okay. Constrain this face on this face, apply, and the other, which means this one, to be applied on this face. Okay, all we can do is the placement of the squares here. In conclusion, we see that we can create parts with one or more parameters which can be exported and used to create an iFactory for placing that parts in various positions of an assembly. That's all for today. Thanks for watching. Bye bye.